Hey, Andrew. It'll be easier for me to explain this by video than trying to do it by text message. It looks like you've got everything set up correctly up until here. Before we address the factorials, the three inside the absolute value can be separated since it's part of the multiplication problem, and the absolute value of three, of course, is three. So we could pull the three out and go ahead and take its absolute value. And technically speaking, the factorials are positive as well, so we don't really need those absolute values. It wouldn't be wrong if you left them, but I'm going to leave them off only because everything that's not the negative three that we took the absolute value of. The rest of it's still positive, so we don't need the absolute value. Yeah, we're going to get some mass cancellation, and the trick to doing it is to start expanding the factorials. I would always start with the one with the larger number, which is the 2n plus 3 on the bottom. If you expand 2n plus 3 factorial, it starts with 2n plus 3, and then you just lower it by 1 until you get all the way down to 1. So if I lower that by 1, I get 2n plus 2, and then 2n plus 1, and then 2n, and then all the way down to 3, 2, 1. And then I think you can probably see where this is going now. And on the top, if we expand the 2n plus 1 factorial, it's 2n plus 1, and then 1 less than that is 2n, and then it goes all the way down to 3, 2, 1. I don't need a parentheses there. But anytime you have a ratio of factorials and one of them is larger than the other, which means one is smaller than the other, then the smaller one will totally get wiped out by most of the larger one. And the real question is what's left over. At this point, it becomes pretty easy to finish because you get 3 times the limit. Wait a minute, we should have some x's somewhere. Oh, wait, I'm going to speculate that you're checking the convergence at the endpoints of the interval. So you already found the interval. Now you're just letting x equal one of the endpoints. But anyway, at this point, we get a limit as actually, yeah, okay. Anyway, what's left over goes to 0 because the numerator is now 1. The denominator is a polynomial, so it's going to blow up. And so this converges to 3 times 0, which is 0. So the series that you threw up there, number 24, wait a minute, this is 8.4, 8.5. Oh, 8.4. So, okay, so this wasn't an interval of convergence question. This was just, does the series converge? You're doing the ratio test, and the limit is 0, which is less than 1, which means the series converges absolutely. So, but in terms of what to do with the factorials, yeah, anytime you get a ratio of factorials, unless they match exactly, in which case it would cancel, one of them is going to be smaller than the other and get totally canceled by part of the larger factorial. And then it's just what's left over and then what happens afterwards. Hope this helps. If you have any other questions, just shoot me a text.